There is a country whose engineering culture is defined by a single word, a word that has no perfect English translation, though it is sometimes rendered as continuous improvement, or as the relentless pursuit of perfection through incremental refinement. It describes an approach to manufacturing and design that does not accept that good enough is ever enough. That treats every flaw, however small, as an opportunity. The word is Kaizen, and the country is Japan. Most people associate Japanese engineering precision with consumer electronics, automobiles, and high-speed trains, with products where millimeter tolerances and zero-defect manufacturing define the competitive landscape. What most people do not associate with Japan is machines that weigh 800 metric tons and stand 6 stories tall. And yet Japan has produced exactly that. The Hitachi EX8000 is one of the largest hydraulic mining excavators ever built. The engineering culture that produced it is present in every weld, every hydraulic circuit, and every electronic control system. Hitachi Construction Machinery has been building excavators since the 1960s. Their development path from small equipment to 800-ton mining giants traces a continuous arc of engineering development. The EX8000 is not a sudden leap. It is the current point on a trajectory Hitachi has been following for 60 years. But before we get into what makes the EX8000 extraordinary, we need to understand the market context it entered. It arrived in a market already served by the Bucyrus RH400, the Liebherr R9800, and the Caterpillar 6090 FS. Entering that market successfully required Hitachi to bring something more than size. It required them to bring a distinctly Japanese engineering perspective to a class of machine where that hadn't been applied. The Kaizen approach applied to a machine this large produced results that surprised the industry. Smaller improvements across more dimensions, compounding into a total performance advantage. But that's not even the most interesting part of this story. The specific applications reveal why the right machine for one application is not always the right machine for another. The Hitachi EX8000 has an operating weight of approximately 810 metric tons in its standard mining backhoe configuration. This places it in the same weight class as the Liebherr R9800. Both machines are in the 800 metric ton range. This represents the current upper boundary of the hydraulic backhoe excavator category in regular production. The convergence of these weight figures reflects engineering reality, similar to ultra-class haul trucks converging on 363 metric ton payloads. The bucket capacity of the EX8000 is approximately 40 to 52 cubic meters, depending on the material density of the application. For typical copper ore applications, a 40 to 45 cubic meter bucket is standard to handle the higher density material. For lower density coal applications, a larger bucket with higher volume but lower structural load is more appropriate. This flexibility means a single machine platform can be optimized for different mines rather than requiring different machine models. The EX8000 can load 363 metric ton ultra-class haul trucks in approximately 4 to 5 passes in typical copper applications. In lower density coal, it reaches capacity in just 3 passes. This positions the EX8000 as a genuine competitor in its class. The overall height reaches approximately 20 meters, roughly the height of a 6-story building. The crawler undercarriage spans approximately 10 meters in width, wider than 3 standard traffic lanes. 2 diesel engines power the EX8000, providing a combined output of 3,000 to 3,500 horsepower. The hydraulic system operates at pressures up to 350 bar, with enough flow to operate all functions simultaneously at full speed. This allows the operator to begin the swing motion while the bucket is still completing its crowd and hoist sequence. The overlap of functions can reduce cycle time by several seconds per pass, compounding into significant daily productivity differences. The crawler undercarriage uses extra-wide steel pads to maximize ground contact and minimize the ground pressure exerted. Hitachi's specific track geometry and final drive configuration reflect a set of design choices optimized for specific market priorities. Understanding these differences reveals the unique engineering cultures that produce these incredible ultra-large mining machines. Hitachi's approach to the EX8000's hydraulic system design reflects the same philosophy that characterizes Japanese manufacturing generally, not the pursuit of the maximum possible performance at any cost, but the pursuit of the best balance between performance, reliability, and maintainability across the machine's full operational life. This distinction matters more than it might initially appear. A hydraulic system designed for maximum performance, maximum flow, maximum pressure, maximum speed, can deliver impressive specifications, but may compromise reliability and maintenance intervals in ways that increase total cost of ownership. A hydraulic system designed for the best balance of performance and reliability, slightly lower peak flow rates, slightly more conservative operating pressures, slightly more margin in thermal management, may produce modestly lower peak specifications, but deliver better uptime, longer component life, and lower maintenance costs over the machine's operational lifetime. Hitachi's philosophy leans toward the balanced approach. The EX8000's hydraulic system is not designed to produce the maximum possible outputs. It is designed to produce the best total cost of ownership across a machine life measured in tens of thousands of operating hours. The specific choices, pump sizing, circuit architecture, valve specification, cooling system capacity, reflect this philosophy in ways that are not visible in a specification comparison but become apparent in operational data accumulated over years of service. This philosophy extends to the structural design. Japanese automotive and manufacturing companies are known for their use of finite element analysis and fatigue life modeling in product development. Computational tools that identify stress concentrations, predict crack initiation sites, and allow structural optimization for the specific load cycles a component will experience in service. Hitachi applies these same analytical tools to the EX8000 structural design with a thoroughness that reflects decades of experience with both the analytical methods and the specific load conditions of large hydraulic excavator operation. The result is a main frame, boom, and stick design that is not necessarily the lightest possible structure or the stiffest possible structure, but that is the best structure for the specific combination of loads, load cycles, environmental conditions, and maintenance practices that the EX8000 encounters. The welds, always the critical points in large welded steel structures where fatigue cracks are most likely to initiate, receive specific attention in terms of weld procedure, post-weld treatment, and inspection protocols that reflect the Japanese manufacturing tradition of treating weld quality as a primary concern. The electronic control systems of the EX8000 reflect Hitachi's strength as an electronics and systems integration company. Unlike some manufacturers that source electronic control systems from third-party suppliers, Hitachi develops many of its core control system components in-house. This vertical integration gives Hitachi more complete control over the performance and behavior of the machine's electronic systems, more ability to optimize the interaction between the hydraulic control system, the engine management system, and the machine monitoring system. The HIOS 3 hydraulic system, Hitachi's proprietary hydraulic intelligence system, manages power distribution to optimize performance and fuel efficiency simultaneously. The system monitors the load on each hydraulic circuit in real time and adjusts pump output to match actual demand rather than producing maximum flow. This load sensing approach reduces fuel consumption during periods of partial load, when the machine is swinging rather than digging, for example. The fuel savings from this approach, accumulated over thousands of operating hours, are significant. What happened when Hitachi first began testing the HIOS 3 system was a confirmation that the fuel efficiency improvement was real and consistent. The system's ability to adapt to the constantly changing load conditions, the rapid transitions between full load digging, partial load swinging, and low load positioning, produced fuel consumption figures consistently below what fixed output hydraulic systems achieved in comparable applications. And fuel, At the consumption rates of an 800-ton excavator over thousands of operating hours represents a major operating cost. Consistent fuel savings matter enormously. But the most distinctively Japanese element of the EX8000's design is the approach to serviceability. It is the deliberate engineering of the machine to be maintained easily, correctly, and safely by the mechanics, who will work on it for the machine's entire operational life. Japanese manufacturing philosophy has long placed serviceability, the ease of maintenance, on the same level of importance as initial performance. This reflects a total life cycle perspective that values the cost and difficulty of ownership as much as the capability at purchase. For consumer products, this means easy access filter panels and maintenance schedules designed around the realities of how actual users service their products. For an 800-ton mining excavator, serviceability means something different in scale, but identical in principle. It means hydraulic filters are located where a mechanic can reach them without specialized lifting equipment. It means engine oil drain points are positioned where spent oil can be collected without contaminating the ground. Boom and stick pin connections are designed for access with standard tools rather than requiring partial disassembly of the machine. Electronic diagnostic ports are located in the cab or at ground level for easy data reading by the maintenance team. These are practical engineering achievements that matter enormously in harsh, real-world operational environments where maintenance is often performed under pressure. A machine that makes the job easier gets better maintenance. A well-maintained machine runs better and lasts longer. Hitachi's service engineering also includes comprehensive training programs, providing both classroom instruction and hands-on technician training. This structured knowledge transfer ensures operators understand how to identify and address issues before they become expensive failures. The machine is designed to be maintained correctly, and the people are trained to do it correctly, validating the engineering investment. This reflects a Japanese industrial culture that treats the relationship as a long-term partnership rather than a one-time transaction. In operational comparisons, Hitachi units have consistently achieved availability rates competitive with or superior to Western alternatives. High availability translates directly into production. A machine with more uptime does more work, leading to better economics. The chain from serviceability to economics is direct, making the X8000 a global success in the most demanding markets. The Hitachi EX8000 has been deployed in mining operations across Australia, South America, Africa, and Southeast Asia. The Australian iron ore and coal sectors have been among the primary markets for EX8000 units. Australian mining operators are known for rigorous equipment evaluation processes and detailed total cost of ownership analysis. The EX8000's success against competition from Liebherr, Bucyrus, and Caterpillar is a meaningful endorsement of the machine's competitive position. In the iron ore operations of Western Australia's Pilbara region, EX8000 units work in the banded iron formations. The combination of hard rock conditions and high production requirements creates a demanding test of the machine's design. The EX8000's performance has made it a standard option in the fleet specifications of major operators like BHP and Rio Tinto. In South American copper mining, EX8000 units face the altitude challenges of the Atacama Desert and Andean porphyry deposits. Hitachi's high-altitude engine configurations address power reduction from low air density with turbocharged and intercooled setups. Thermal management systems are calibrated for high-altitude, high-insulation conditions that can make machine cooling challenging. In coal mining applications, the EX8000 in its high-volume bucket configuration competes effectively with coal-optimized versions of other machines. The larger bucket capacity improves loading rates and reduces the passes per truck metric for ultra-class coal haul trucks. The X8000's market position reflects a sustainable competitive strategy distinguished by Hitachi's Japanese engineering culture. Consistently competitive, consistently reliable, and consistently supported by a manufacturer's service and training commitment. Hitachi Ltd. is one of the largest industrial conglomerates, with capabilities spanning power, rail, and information technology. Engineering talent drawing on expertise in electrical systems gives Hitachi capabilities that pure mining specialists cannot fully replicate. Autonomous operation technology, allowing the EX8000 to work without an onboard operator, is an active area of development. Hitachi has demonstrated prototype autonomous capabilities on smaller machines, moving toward the EX8000 class. Integration of IoT and data analytics will produce machines optimized within the complete production system of the mines. The electrification trend will eventually reach the large mining excavator segment as battery technology matures. Hitachi's transition will be facilitated by its experience with electric drive systems in rail and industrial businesses. Stand on the observation platform of a working EX8000 and look down at the bucket as it engages the face below. The hydraulics are at pressure. The bucket teeth are in contact with the rock. With smooth power delivery, the material yields. The bucket fills, the boom rises, and the machine swings. In 30 seconds, the cycle is complete. The truck below has received material that powers the world's economy. That is what 810 metric tons of Japanese engineering precision looks like when it is doing what it was built to do. Kaizen, applied at 810 tons. In the hardest mines on Earth, that is the Hitachi EX8000. Next, we move from a machine that digs to a machine that drills. The Sandvik DR416i, a machine whose precision determines the quality of every blast and the efficiency of every excavator. We are just getting started.